Assalamualaikum everyone. Today I wanna doing some questions that I got wrong in my final year exam 10th graders. So we move to the first question that I got wrong question answer I mean yeah so it's wait number two the ion X2 plus has the same electronic configuration as the atom krypton. What is the electronic configuration of an atom of X? So we get three steps here. The first step is find the electronic configuration of krypton. Krypton is a noble gas with atomic number 36. Its configuration ends at the fourth period. Argon 4s2 3 to 10 4p6. Step 2. The ion X2 plus has lost two electrons to achieve this stable configuration. Therefore, the neutral atom X must have two more electrons than krypton. Or step 3. Adding two electrons to the krypton configuration means filling the next available subcell, which is the 5s orbital. So the configuration of X is argon 4s2, 3 to 10, 4p6, and 5s2. So the correct answer is B. Is B. Next, a radioactive isotope of thallium is used to access damage in her muscles after a heart attack. Which statement about thallium is correct? So we have to examine it's the answer so we can get the wrong as the correct assignment. So we start from the A. This isotope has a nuclear number of 120. So the nuclear or mass number is the top number, which is 201, not 120. So the A choice is incorrect. The second B for a neutral atom. Wait. The number of electrons in one atom of this isotope is 81. Okay. For a neutral atom, the number of electrons equals the atomic number, the bottom number, which is 81, and it's correct. So the correct answer is B, and the rest is wrong. Next, methane and steam react to produce hydrogen. 0.8 gram of methane and 1.35 gram of steam react. One of the reactants is caesar. Which volume of hydrogen measured at room conditions will be produced? So we have four steps here. The first step is we have to calculate moles of reactants. Mole of CH4 equals to 0.8 grams per 16 grams per mole equals to 0.05 mole. Moles of H2O equals to 1.35 grams divided by 18 gram per mole. So it equals to 0.075 mole. Step we have to find the limiting reactant. According to the equation, 1 mole of CH4 requires 2 moles of H2O. To complete the react 0.05 mole of CH4, we need 0.05 times 2 equals 10 equals 0.10 mole of H2O. Since we only have 0.075 mole, H2O is the limiting reactant. Step 3. Calculate moles of H2 produced. From the stoichiometry, 2 moles of H2 produce 4 moles of H2. So the moles of H2 is 0.075 mole times 2 is 0.15 mole. And the last we have to calculate the volume. The volume is 0.15 mole times 24 dm to the power of 3 per mole equals to 3.6 dm to the power of 3. So the correct answer is B. Next, the use of data booklet is relevant to this question. The gas law can be summarized in the ideal gas equation below. PV equals to nRT. The volume of a sample methane is measured at a temperature of 60 degrees Celsius and a pressure of 103 kilopascal. Volume measure is 5.37 times 10 to the power of minus 3 m to the power of 3. Some of the gas behaves as an ideal gas. What is the mass of the sample of methane given the two significant figures? So the first step is we have to convert all to S1, and after that we can calculate the moles or N. N equals to PV per RT is 103,000 times 5.7 times 10 to the power of minus 3 divided by 8.31 times 333 is close to 0.2 mole. So the last step is we have to calculate the mass. Mass equals to moles times molar mass of CH4 equals to 0.2 times 16 gram per mole or 3.2 gram. So the correct answer is D. Sodium azide entry is an explosive used to inflate airbags in cars when they crash. It consists of positive sodium ions and negative azide ions. What are the numbers of electrons in the sodium ion and the azide ion? So the sodium ion Na plus is a natural sodium atom that has 11 electrons. The plus 1 charge means it has lost 1 electrons. 11 minus 1 is 10 electrons. Azide ion or and minus 3 is a natural nitrogen atoms the 7 electrons. 3 nitrogen atoms give 7 point multiples by 3 is 21 electrons. The minus 1 charge means it gain 1 electron or is equals to 22 electrons. So the correct answer is B. The structure of the sulfur dioxide molecule is shown. What's the shape of the sulfur dioxide molecule? Looking at the central sulfur atom in the provided diagram, it has two bonding regions and one lone pair of electrons on top. The total electron pair geometry is trigonal planar. But because one position is occupied by a lone pair, the physical molecular shape is band or non-linear. The correct answer is B. In which pair do the molecules have the same shape as each other? So we have to check all of the answers again. We move to the B option. H2O has a central oxygen atom with two bonding pairs and two lone pairs, band or non-linear. HCl2 has a central sulfur atom with two bonding pairs and two lone pairs, is band or non-linear. No, this H2O band for still linear and H3 pyramidal first BH3 trigonal planar. So the correct answer is B. Sample of magnesium contains the isotope 24 Mg25 magnesium and 26 magnesium only. The percentage abundance of 25 magnesium and 26 magnesium is the same. The relative atomic mass of magnesium is the sample in the sample is 24.3. What's the percentage abundance of 24 magnesium? So we have to set up the equation first. We have to set up the abundance of 24 magnesium is x. Since the remaining percentage is pre-equality between 25 magnesiums and 26 magnesiums. The abundance are each 100 minus x per 2. So we have to set up the weighted average molar is 24.3 equals to 24x multiples by x plus 25 multiples by 100 minus x per 2 plus 26 times 100 minus x per 2. And then we have a long process. And then we got the x is 80%. So the correct answer is D. So which diagram represents the overlap of two orbitals which will form a p-bond? A p-bond is formed by the sideways or lateral overlap of two parallel p orbitals. Diagram B clearly displays two p orbitals sitting vertically side by side, overlapping at both at top and bottom lobes. So the correct answer is B. The student mix 25.0 centimeter cubic of 4 mole dm to the power minus 3 hydrochloric acid with an equal volume of 4 moles dm minus 3 sodium hydroxide. The initial temperature of both solutions was 15 degrees Celsius. The maximum temperature reached was 30 degrees Celsius. The heat capacity of the final solution can be assumed to be 4.18 joule K minus 1 G minus 1, and the density of this solution can be assumed to be 1 gram centimeter to the power minus 3. Using this result, what is the enthalpy change of the neutralization of hydrochloric acid? So we have to calculate heat energy first. We have to know the total volume of solution, which is 25 plus 25 equals to 50 centimeter cubic, and or the mass is 50 gram. delta T equals to 30 minus 15 equals to 15 degrees Celsius or 15 Kelvin, 15 K. Q equals to MC delta T, which is 50 grams times 4.18 joule K gram minus 1 K minus 1 times 15 K equals to 3135 J equals 103,135. Next step, we have to calculate the moles of HCl is the moles of NaO equals N equals is to 25 divided by 1000 times 4 is equals to 0.100 mole. And last step, we have to calculate the molar enthalpy change. Delta H or enthalpy change is minus K per N. And we have to divide it 3135 kilojoule per 0.100 mole. And then in the end, we got minus 31.4 kilojoule mole minus 1, I mean. The correct answer is B. The carbon monoxide and methanol can react together to form ethanoic acid. Standard enthalpy change of combustion are given in the table. What is the value of delta H for the reaction between carbon monoxide and methanol? What is the value of standard enthalpy change of combustion? Okay, we have to use the Hess first with the combustion data. So the enthalpy change of combustion equals to sigma delta H sigma enthalpy change of combustion plus HCO plus delta H combustion CH3OH OH minus delta H CH3 CO2 OH. And the end after we calculate bit long, we have the enthalpy change of combustion is 1 minus 1009 plus 874.1 equals to 1 minus 13 minus 134.9 kilojoule mole minus 1. The correct answer is B. In the conversion of compound X into compound Z, it was found that the reaction of proceed by way of compound X, Y, which could be isolated. The following steps were involved. X to Y is delta H positive. Y to Z is delta H negative. Which reaction profile is this data? X to Y is endothermic. The energy level of intermediate Y must be higher than reaction X. Y to Z is exothermic. The energy level of product Z must be lower than intermediate Y. Looking at the profile, graph C shows X climbing up to a higher energy state, Y, then dropping down to Z. So the correct answer is C. What is the definition of standard enthalpy change of neutralization? Delta H combustion. By strict textbook definition, it is the enthalpy change when an acid and alkali reacts to form 1 mole of water under standard conditions. So the correct answer is D. Sulfur can be oxided in two ways. Sulfur dioxide can be made from sulfur dioxide and oxygen. What is the standard enthalpy change for this reaction? So we have to reverse equation 1 and multiply it by 2. So we can make this equation same. So we got 2SO2 gram, 2 S plus 2O2 gram. So the enthalpy change is plus 20 plus 296.5 times 2 is 593.0 kilojoule mole. So keep the equation 2 exactly as it is. We got the enthalpy change is minus 756 791.4 kilojoule mole minus 1. So and both just adjust the equation together and we got the enthalpy change is plus 593 plus minus 791.4 equals to minus 198.4 kilojoule per mole minus 1. So the correct answer is D. The enthalpy change for neutralization of HNO3 aqueous with NaOH aqueous is minus 57 kilojoule per mole minus 1. In experiment, 20, 20 centimeter cubic of 4 mole DM to the power of minus 3 and NO3 is mixed with uh, 30 centimeter cubic of 2 mole DM minus 3 and NaOH in an insulated container. The initial temperature of bar solution is 25 degrees Celsius. It can be assumed that the heat capacity of the product mixture is 4.2 joule centimeter to the power minus 3 uh, degrees Celsius minus 1 and that there are not heat losses. That's the maximum final temperature of the mixture. So we have to know the moles of fractions. Moles of HNO is equals to 0.02 times 4 equals to 0.08 mole. Most of NaOH is 0.03 times 2 is 0.06 mole. Then we have to know the rate release. The release or Q is moles times delta H or enthalpy change equals to 0.06 mole times 50,000 joule per mole equals to 33420 joule. Step 3, temperature change or delta T. We have to know total mass of solution is 20 plus 30 equals to 50 gram. The heat release or Q is mc delta T. So the 3420 equals to 50 times 4.2 times the temperature change. 3420 equals to 210 times delta T. Delta T is 16.29 degrees Celsius. Last final temperature, we have to know the temperature final is 25 plus 16.3 equals to 41.3 uh, degrees Celsius. So the final answer is A. The standard enthalpy change of combusting glucose and ethanol are given as minus 2080 minus 2820 and minus 1368 kilojoule more minus 1 respectively. Glucose can be converted into ethanol. What is the standard enthalpy change for this reaction? So we have to note that carbon dioxide is a product of combustion, so its enthalpy of combustion is zero. Applying Hell's law with combustion values, delta H combustion equals to delta H glucose minus 2 times delta H oxygen ethanol. Change enthalpy change of combustion is minus 22820 minus 2 times minus 13 68. So the enthalpy change combustion is minus 22820 plus 2736 is minus 84 kilojoule mole minus 1. So the correct answer is B. In which reaction is the underlying substance acting as a base? By the Brostep-Lowry definition, a base is a proton A, H, etc. Let's look at option A. HNO3 plus H2SO4 is H2O and O plus 3 plus HSO minus 4. Nitric acid or HNO3 donates a proton to sulfuric acid. Sulfuric acid or H2SO4 accepts that proton to become H2NO3 plus. Therefore, it acts as a base here. So the correct answer is A. Four mixtures are added to four spread 50 centimeter cubic samples of water and stirred. which mixture results in a solution with the highest pH. To get the highest pH, we need the most basic alkaline solution. A list of options. B. 1 gram of magnesium oxide, and 1 gram of magnesium chloride, Cl. Magnesium oxide is a basic metal oxide that reacts slightly with water to produce magnesium hydroxide. Magnesium OH2, which creates an alkaline solution pH is close to 9 until 10. Another option contains non-metal oxides or chlorides like phosphorus oxide or silicon chloride, which form highly acidic solution, or aluminum chloride, which hydrolyzes to form an acidic solution. So the correct answer is B. Which mixture will react to form exactly 1 mole of water? The best hydrogen equation of sulfuric acid and sodium hydroxide is H2S H2 H2SO4 plus 2NaOH is 2Na2SO4 plus 2H2O. It shows that 2 moles of NaOH produce 2 moles of H2O 1 by 1 ratio. Therefore, to get exactly 1 mole of water, we need exactly 1 mole of NaOH to react completely with at least zero point 0.5 moles of H2O4 minus. Let's check the option D. Moles of NaOH is 1 mole dm to the power of minus 3 times 1000 divided by 1000 dm power of 3 is 1 mole. Mass of H2SO4 is 2 mole dm minus 3 times 500 per 1000 dm3, which is 1 mole. This is plenty of acid. So NaOH remains the reaction and produces exactly 1 mole of water. So the correct answer is D. Because acid P and aqueous alkali Q has the same concentration, 20 centimeter cubic of P is added to a conical flask. Q is slowly added to the flask and the volume of P and the pH are recorded. The pH titration curve is shown, which row gives the identifier of P and Q. Looking at the graph, the initial pH before any alkali is added is extremely low, around pH 0.5. This indicates P must be a strong acid, or weak electronic acid in option D. The equivalence point occurs when exactly 10 centimeter cubic of alkali Q is added to 20 centimeter cubic of acid P. Since P and K have the same concentration, needing half the volume of alkali makes 1 mole of K neutralize 2 moles of P. If P is a monoprotic strong acid or HCl, then K must be in the protic BHO, BaOH2, so that the residual 2HCl plus BaOH2 is BaCl2 plus 2H2O. So the correct answer is C. In which reaction is well behaving as a Bronsted Lowry base? For water to act as a Bronsted Lowry base, it must accept the proton H plus to turn into the hydronium ion H3O plus. Let's look at the option B. S2 plus S3PO is H3O plus H2PO minus 4. Phosphoric acid runs a proton and water accepts it. So called SSB. Sulfur dioxide is used as a preservative in winemaking. The following equation describes how sulfur dioxide dissolves. Which statement about these two reactions is correct? Equation 1. H2O plus SO2 is HSO minus 3 plus H plus. Equation 2. HSO minus 3 plus HH is SO2 minus 3 plus 2H plus. Looking at equation 2 in reverse, SO2 minus 3 accepts a proton plus to become HSO minus 3. Accepting a proton is a definition of base. Therefore, working backwards, HSO minus 3 acts as a base when the system shifts left. So the correct answer is A. So this is the last question of paper 1. For solutions, its concentration 0.1 mole dm to power minus 3. We are tested with a pH meter. The results are shown. What statement explain this result? Acid 2 has a lower pH than acid 1 because it is more soluble. Base 2 has a higher concentration of hydroxide ions in solution than base 1. Acid 1 dissociates less than acid 2. Statement 1. Acid 2 has a lower pH than acid 1 because it is more soluble. Incorrect. HNO3 has a lower pH because it is strong acid that fully dissociates, not because of solubility. Statement 2. Base 2 has a higher concentration of hydroxide ions in solution than base 1. Correct. NaOH is strong base pH 14, which is completely dissociated to release more OH ions than weak base methylamine like pH 11. Statement 3. Acid 1 dissociates less than acid 2. Correct. Cyanuric acid or acid 1 is a weak acid, meaning it only partially dissociates compared to nitric acid or acid 2. Since statement 2 and 3 are correct, so the correct answer is C. So we move on to the paper 2 questions. We got our first question here. Atoms contain the subatomic particles, electrons, protons, and neutrons, but those electrons were discovered by observation of their behavior in electric fields. The game shows the behavior of spare beams of electrons and protons in the electric field. Complete the diagram with the relative charge of each other electrically charged place. So the diagram in the left charge place is minus because the positive atom beam is attracted to it. And in the right plate is positive because the negative electron beam is attracted toward it. So the second is on the diagram draw a line to show a house beam of Newton from the same source behave in the same electric field. So this we have to draw a straight line extending the source out through the top center without any bending because the neutrons not charged and are unaffected by electric fields. Next B, atom is atom up to 36 krypton are distributed in sp and d orbitals. Set the number of occupied orbitals in an atom of 36 krypton. So the S-type number of metal have 4. The S-type is 1 S2 to S2 38 4 ps. The P-type is 9 orbitals or the NDT type has 5 orbitals. Here, this is the equation orbitals. Next, complete the diagram to show the number and relative energies of the electron in an isolated atom of 14C. So 1 S2 to S2 3 S3 we fill each box with 12 sides pointing around toward up toward down. So P fill all 3 boxes with opposite arrows like the first one, but it's 3 in a row. 3P put a single upward arrow into the first box. 3P and single upward arrow 2 on the second box and the third box let it be empty to follow the Hans rule. And for S leave completely empty. Next B3 diagram shows a type of orbitals. State the total number of electrons that exist in all orbital of this type in an atom of 9F. So the diagram displays a p orbital. So its electron on configuration is 1s2 to s2 to p5. So the answer is 5. Next, chromium or Cr and its compounds are widely used in many chemical reactions. Cr exists as four stable isotopes. The most common isotopes of Cr is chromium 52. Determine the number of protons, neutrons, and electrons in an atom of chromium 52. Number of proton is 24. Number of neutrons is 28 and electron is 24. Describe how an atom of chromium 54 differs from an atom of chromium 52. Refer to number of particles in your answer. The answer is chromium 54 has 2 more neutrons than chromium 52, 30 neutrons compared to 28 neutrons. The shorthand electronic configuration of chromium is argon 3254S1. Complete the full electronic configuration of chromium. 1 is 2, 2 is 2, 2 P6, 3 is 2, 3 P6, and last 2 is 3 D5, and 4 S1 is in the question. Next, deduce the total number of unpaired electrons in an atom of chromium. Is 6 because 5 in the 3D subcells plus 1 in the 4s subcell. Most elements exist naturally as mixture of isotopes, each with their own relative isotopic mass. The mass spectrum of an element reveals the abundance of these isotopes, which can be used to calculate the relative atomic mass of the element. Magnesium has three stable isotopes. Information about two this isotope is given. So we get the information on the box here. The relative atomic mass of magnesium is 24.3. Calculate the percentage abundance and hence the relative isotopic mass of the third isotope of magnesium. If you answer three significant figures. So first step we have to find the percentage abundance of the third isotopes of 25 milligrams. The percentage abundance is 100% minus 75% minus 11% is 10%. 10% is the percentage of abundance. And then we have to calculate the isotopic mass using the weighted average formula. 24.3 is 24 times 75 plus 26 times 11 plus m times 10 per 1 divided by 100. So we have to calculate all of this like this, and we have the 248 equals to 10 m. M is 24.8. So answers to right percentage abundance is 10%, and isotopic mass is 24.8. Next. Cobalt, rhodium, and iridium are metals in the same group of periodic table. A. The short and electronic configuration of cobalt is R3D74S2. Identify what is meant by R by giving its full electron configuration. So the answer is it represents the core electron configuration of the noble gas. Argon 1s2, 2s2, 2p6, 3s2, 3p6. Lowest energy electrons in cobalt are in the 1s orbital. Draw the shape of a 1s orbital. So the shape of 1s orbital is this perfect circle like this. Next, deduce the number of unpaired electron in a cobalt atom. So it's 3 because the 3D orbitals of cells has 5 space. 2 are paired up, leaving 3 slots unpaired. Table 1.1 gives some details of the stable naturally occurring isotopes of rhodium and iridium isotope. Number of protons is 45. Number of neutrons is 50x. So the total number of electron cells is 5. The iridium, the number of protons is 77. The number of neutrons is 104, 114. And the total number of electron cell is 6. The number of protons of iridium is 77. Number of neutrons is 116. Total number of electron cells is 16 because we got in the first one. We see number of protons is 45. So the total number of electron cells is 5. The iridium, the number of protons is 77. Number of neutrons is 191 minus 77 equals to 114. Next, the iridium, the number of protons is 77. Number of electron is 193. So we subtract it by 77. We got the 116. Table 1.2 shows the relative abundance of each isotope in a sample of an alloy containing rhodium and iridium only. So this is the information about the box. I mean the box of information of the isotope. The answer is in the next slide. Use table 1.2 to calculate the relative atomic mass air of iridium in the alloy. If you answer to the decimal places. So when we want to calculate the relative atomic mass of the iridium, we have to use the data for the iridium table 2. Air equals to 190.96 times 15.18 plus 192.96 times 34.82 divided by 15.18 plus 34.82. So we calculate all of this and we got now 192 0.3528. We rounded to two decimal places. We get a 192.35. Next, a sample of iron contains three different isotopes and has a relative atomic mass R or 55.8. Define the relative atomic mass. Answer. The weighted isotope first mass of an atom of an element relative to 1 to 12 the mass of a carbon 12 atom. Table 2.1 shows the abundance of two of the isotope places in the sample of iron. So this is the information. Use the table 2.1 to calculate the relative atomic mass of the isotopes of iron in the sample. So you're working. So this is the working. First, we have to let the abundance of third isotope to get the 2.1%. Then we have to import it in the formula. 55.8 equals to 53.9 times 6 plus 55.6 times 91.9 plus m plus times 22.1 divided by 100. We calculate it and we got about 56.9. So the answer is 56.9. And B, reduce the number of penetrating the cells in the iron. We got one because in a 3D6 subcells, one orbital holds a pair of electrons while the remaining four hold single electrons. So that's is one. So in the sketch a shape of the lowest energy orbital in the cell will be simple quantum number. So the lowest energy of the orbital is just like a normal and simple speed. Next. Define enthalpy change of formation. So, the enthalpy change when one mole of a compound is formed from its constituent elements in the solid state under standard condition. First is made when iron trioxide is heated with carbon monoxide as shown by the reaction of two. Section 2. Table 4.1 shows the enthalpy change of formation data measured at 298 K and 101 kilopascal. So the equation for Fa2O3 is 2FeS plus 3 per 2O2G 2Fe2O3S. CS plus a half of O2G 2BCOG. And CO2 is just like in the question. Complete number 4. Yeah, we already done the completing the table 41 for Fa2 and 2. Next is the data in the table 4.1 to calculate the enthalpy change of reaction the HR in kg mole minus 1. So you're working. So we have to calculate the enthalpy change of reaction or the HR by this equation. I mean this formula. So we input all the number in here information and we calculated and the answer is minus 24.8. This is the last slide. So let's do it. A molecule of HCl2 contains two HCl covalent bonds. Complete the dot and cross diagram in Fig 2.1 to show the arrangement of the outer electrons in a molecule of HCl2. Use the times to solve. Use point to solve. So this is the drawing of mine. This is drawing of mine. I think it's correct. Then predict the shape of Predict the shape of and bond angle in a molecule of Cl2 by using VSEPR theory. So the shape is bend or non-linear and bond angle is 104.5 degree, except anywhere between 104 degree to 105 degree. Table 1.1 give the data. Yes, this data about reaction to this. Use the data in the table of to calculate the change variation of general with the end. So when we calculate the entropy change ratio, we have to state the target action given by standard textbook pattern here. Is Cl2G plus N2N S3G to be NH4 CL3S plus HLG star interactions. But let's check basic parents gas transformations even evaluates direct edge products. The HR or the enthalpy change is formula So we import all the number and we got minus 184 kilojoule mole minus 1. So this is 108 kilojoule mole kilojoule per mole. Okay, I think that's all from me. Thank you very much for listening. I'm sorry because I know I have mistakes in the spelling and doing the question to get the right answer. I'm just a student and I'm not good at chemistry, but at least I try. So thank you very much. Assalamualaikum warahmatullahi wabarakatuh.